Let's take a look at the problems in number 5. There are like 12 problems here, so I'll do 4 at a time so that you don't have to listen to, the first 6 problems if you only want to, get some help on the 7th problem. So the first video here, I'll do 5A through D. So determine whether each statement is true or false. If the statement is false, you have to change the statement so it's true by changing the actual statement itself, or you could show a counterexample which tells you why the statement is not true. So the first problem here says 4 to the negative 2 is less than 4 to the negative 3. So let's write out what 4 to the negative 2 means. That means 1 over 4 squared, which is the number 1/16. 4 to the negative 3 says 1 over 4 cubed, which is 1 over 64. So 1/16 and 1/64 are the two quantities that we are trying to compare. So our question says that this quantity, 1/16, is less than this quantity. And we know that when our denominator gets larger, as long as our numerators stay in the same, our size is getting smaller. In other words, if I had some type of pizza, for example, which is the famous example, right? And I divided it into 16 slices and took a slice, that would be a bigger slice than if I took a pizza and divided it into 64 slices and took one of them. So 1/16 is greater than 1/64, so this is a false statement. So how could you change this statement to finish the directions? You could do this. Okay, that would be one way to change it. The set of all excluded values for the rational expression 1 over x squared minus 4 is 2. The answer would be x equals 2. That's the only value that you would have to exclude from x here for this fraction, this rational expression, to make sense. Well, to really see if that you've gotten all the possible numbers to exclude, you have to factor x squared minus 4. And x squared minus 4 factors as follows: x minus 2x plus 2. So you can see there are 2 different factors here, so there's going to be 2 different values that you have to exclude. X cannot be 2, which is what we have there, but x can also not be negative 2, because both of these values make our denominator 0. So one way to change this sentence so it's true is you would write negative 2 comma 2. You could say is not the solution set 2. You could just throw a little word not in there. That's another way to do it. Okay, so I'm just giving you some ideas as to how you can change these sentences. C. The cubed root of negative 8 is not a real number. Okay, so a real number is a number that exists on our number line. And so we have to look at the cubed root of negative 8. So is there a number I can multiply 3 times to get negative 8? And the answer is yes, negative 2. And negative 2 certainly is a real number. So we would say the cubed root of negative 8, we could cross out the not there and say is a real number. That would be sufficient. Or you could actually show that the cubed root of negative 8 is negative 2. Okay, finally we have the intersection of 2 sets of numbers. And it says that this intersection is all the numbers on the interval from -4 to -1. So I like drawing little number lines here and comparing my sets. That helps me out a little bit. So -infinity to -1. So I would do something like this. And I'm going to include all these numbers. And I'm going to put a solid dot there. And then -4 to +infinity. So let me see, I want to line these up. So -4 would be right about here. I'm going to include the -4 and go all the way to the right. And so if I intersected these two sets here, I would come down like this, like it was raining, and see where these two sets of numbers overlap. And it looks like they overlap from -4 to -1. So this is a true statement. They both contain all the numbers from -4 to -1.